Hello again, this is part 2 of the PVA intro lesson. Before going any further, I just want to clarify what I mean by traveling in one direction. And see, that's really why I had chosen the zombie as the model for the movable object. What these questions will be focusing on is an item that can only move in one specific direction or backwards. Just forward and backward. Only one item, one path, forward and backwards, which is why I'm going to be using the x-axis to track its movement. Now that movement can vary, but what is not going to happen is the item will not be going around in circles, not going to be jumping up and down, anything like that, nothing crazy, just walking in one path forwards or backwards. Now, can that path be modeled? Yeah, most of the models will come in some sort of function form. So the position function is going to be written as x of t. X representing this position where the object could be either going positive or negative. Now let's say the position function was 1/2 x squared. In this case, time and the function could be modeled as such with a 0. Substitute, you get a 0. 1, you substitute, you get a 0.5. 2, you substitute, you get 2. 3, you substitute. 4, you substitute. 5, you substitute. Now, just looking at this, the object was at the 0 mark in the beginning, so right here at the origin, then the 0.5 mark. So in 1 second, it moved over to 0.5. Then in the next second, it moved to the 2 mark. Then the 4.5 mark. Then the 8 mark. And then moving on more and more. Just looking at these numbers, the zombie is still moving in a straight path, but went from 0 to 0.5 to 2 to 4.5. That movement kept on changing, kept on getting faster and faster, more and more distance traveled every second, but the zombie was still moving on one straight path and was moving forward. So that's what somewhat this means over here. The yellow represents everything that's been talked about before in part 1. So now how will these be represented? All of these items, these 3 quantities, are vectors, and so their directions are going to be noted either by a negative or a positive. Position. Going to talk about that now. Position is a vector quantity, so it has a magnitude and a direction, but it's only moving left or right in a straight line, just like the zombie here. Going to only move right or left. When that x is positive, you're on the right side, but when that x is negative, you're on the left side. So right now, the zombie is on the positive side, still on the positive side, still on the positive side, but looking the other way. Now the zombie is on the negative side and moving left, but you could also be on the negative side but moving to the right, back towards the origin. Velocity. Velocity is also a vector, so it has magnitude and direction. Now, when velocity is positive, it means you're moving to the right. Velocity negative, moving to the left. But also note that moving to the right does not mean you're located on the right. What that means is this. I'm going to be using red arrows to show which way the zombie is currently moving. So I'm going to place the zombie at the 3. Now, since the zombie is pointing this way, the zombie is facing to the right, has a velocity towards the right. That's where its speed is pointing. Now, that speed could be small or it could be large. But the same could also be said from way back here. The zombie could be doing the same thing, even on the negative side. So now the position is negative, but the velocity is positive. It's still moving towards the right side. Velocity being positive only means you're moving in the right direction. Velocity being negative then means that you are pointing to the left and you're moving to the left. This can happen either when you're on the positive side, when your position is positive, when your position is 0, or even when your position is negative. So having a negative velocity does not mean you must be on the negative side. You could have a negative velocity even when you're on the right side, because the position is controlled by the position function. Now going forward, acceleration is also a vector quantity, has magnitude and direction. And when the acceleration is positive, it's feeling a push to the right to change its speed. When acceleration is negative, push to the left to change its speed. And just for clarification, negative or positive acceleration does not mean that the speed, the velocity, or the position are negative or positive themselves. What that means, I'm going to start my object at the 1 mark. The object is moving to the right. If I give it a push in the same direction, what do you expect to happen? It should get faster. So here the velocity is going to get stronger. It's going to get faster and faster and faster. But if the same push was coming in from that side, pointing left, then the acceleration is negative. It's now going to slow the speed down until it stops. The same could be talked about if you're pointing in the other direction. The zombie is moving left, but if it receives a positive acceleration, positive just means to the right. If you can push it to the right, you're actually not helping it at all. It wants to move left, you're pushing it right, you're actually going to be slowing it down. But if you push it left, if you push it negative, if you give it negative acceleration, now the velocity is negative and the acceleration negative, it's going to actually make it get even faster moving to the left side.